how to measure it, correct? And we'll know about the salt solutions, and we'll know about the buffer, correct? So we'll have today there are 6 test tubes. There are 8 here. We need only 6 test tubes, correct? Those 6 tubes here will be numbered 1, 2, 3, 4, 5, 6, correct? So, or 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1 and 2, you fill them with 5 ml of distilled H2O. 5 ml of distilled H2O. 3 and 4, you fill them with the solution buffer pH 3. 5 and 6, you fill them with the buffer solution pH 9. So let me repeat it again. 6 test tubes. 1 and 2, just pure distilled H2O. Don't take the tap. The pH of the tap might a little bit differ from the distilled H2O. A little bit, not that much. But still, the distilled is more, because all your solution you have distilled, not tap, correct? So we have a reference to our solutions. The buffer solutions is made of distilled, not tapper. And then the pH 9. So 1 and 2, H2O, distilled. 3 and 4, pH number 3, the buffer, and the buffer number pH number 9. So those 3, correct? You will measure. You don't have to measure all of the pH without addition. So you'll measure the first one, and the third one, and the fifth one. Remember, 1, 2, 3, 4, 5, and 6. The odd number. Those are without addition. So how we measure the pH? We don't have the pH meter. If you have, it would be nice. But we can still use our pH litmus paper, universal litmus paper, and you know the scales. The scale is given to you here, from 0 to 14 or 13. So the scale is given here. So like we did last week, correct? So you cut small tiny piece, correct? And today you don't have to do any picture today, correct? So not do any picture. So what you will do here, you take a test tube. This is pure H2O, correct? Here you have to rinse it all the time with distilled. Put this one here and smear it. You will smear it like I'm doing here. Smear it, correct? And try to match the colors. And always give yourself a range, because this is a very crude type of reading the pH. There is no distinct one color. So a range. It will look like whatever, greenish yellow. That's between 6 and 7. Give yourself a range, at least one unit. 6, 7, 8, 9, 10, 11. You cannot say this is pH 10. This is by all means is not designed for this. This is get yourself a range of the pH. So now I did the one here, then discard, I mark the color, then I take test tube number 3, all the odd numbers, 3, 1 and 3. So here it is. Rinse this one here, clean it, rinse it, and clean wipe it, and then take the second one. Second one is the pH buffer 3. So here it is, and then I'll match it here. No addition, correct? No addition. So what will happen? I match it. What do you think the theoretical value? If you have done a very good job and the solution is stable, not decomposed, what the pH, the theoretical value will be? What do you think? What do you think? This is buffer solution of the pH 3. So according to the theoretical value will be what? Around what? 3, correct? Correct? Around 3. Maybe 3 to 4, correct? Maybe 3 to 4. You read it a range, so maybe 3 to 4. Are you following? So you know by now what's the theoretical value, because it's given to you, no addition. So 3 to 4 maybe. And then number 5, the pH number 9, correct? Then you come, the same thing here. Let's get the number 5, pure, nothing inside it. Rinse, clean or rinse, and keep wipe this. And then put it in test tube number 5. And then smear it, that's the solution, buffer 9. So the theoretical value will be what? What will be the value? What will be the value? It said the pH buffer, nothing added to it. If the label said 9, which is, if you look at them, they are here. This is buffer solution. This is, here they are, sorry. They are buffer solution number 3, pH 3, and buffer solution 9. According to the values, if there is nothing, no decomposition, and there's fresh solution, we should have pH around 9. You never be exact reading 9 because you have, the litmus paper does not give you distinct one single number range. Maybe between 9 and 10, or 8 and 9. So it will be between 8 and 9, or 9 and 10. And the 3 will be around 2 to 3 or 3 to 4. Has to be a range, because you cannot distinct one single. So now I'm done with testing all those by themselves, nothing added, correct? So 1, 2, 3, 4, 5, 6. 1 and 2 they have distilled H2O. 3 and 4 they have buffer pH 3, and 5 and 6 pH buffer 9. All the odd number, I will add to them 3 drops of sodium hydroxide, correct? And all the even numbers, so 1 and 3 and 5, I will add to them what? Sodium hydroxide, 3 drops, each of those 3 drops. And the sodium hydroxide is here, this bottle here, so can you see? 3 drops of each of those test tubes. Number 1 is distilled H2O, number 3 buffer solution pH 3, and number 5 buffer solution number 9, correct? And the 2, that's even number, test tube number 2, 4 and 6, you'll add to them HCl, 3 drops each, correct? 2 and 4 and 6, you'll add 3 drops of HCl to them. Now, time to measure the pH, correct? Now the H2O, the first one, 1 and 3 and 5, the H2O, you added to it sodium hydroxide. Where we think the theoretical value? So the theoretical value without addition at the beginning, it should around what? 7, correct? Distilled around 7, 6.5, 6 to 7 maybe. So now you added sodium hydroxide to the first one, test tube number 1. So what do you think the pH will be around where? What do you think? Will be acidic, basic, or neutral? You add the sodium hydroxide, will be what? Now you add the base. So number 1 will be basic. So it should read around what? Between 12 and 13, maybe. So theoretical value, maybe around, it should be basic. Number 3 here, pH 3, correct? Number 3, you add the 3 drops of sodium hydroxide. So what will be the value here? Number 3, you add the sodium hydroxide to it. What will be the value? Basic, neutral, or no change? No change. Why? We are dealing with the buffer. So what is the buffer now? Now we know what the buffer is. The buffer is a solution, chemical compound, solution, a combination of course, not a one, is made of a weak acid, which is conjugated base, or a weak base with its conjugated base, acid. So acid with conjugated base, or a base with conjugated acid, means an acid, weak acid with its salt, and base or base with its salt. Everyone's following? For example, acetic acid is acid, weak acid. If I have sodium acetate to it, that's a salt, correct? So acetate and acetic acid, they will make a buffer solution. Meaning what? They will resist the change of the pH of the solution. So this is started with 3. I added 3 drops only of sodium hydroxide. According to the theory, what the pH will be? Remains what? It remains the same. Will be around 3, maybe 3 to 4 range, correct? It will not change. If we have a very good buffer, we did not add too much of the sodium hydroxide. We did not break the capacity of the buffer, correct? So this will remain what? 3, around 3 to 4 maybe. How about number 5? It's pH, buffer pH 9. We added 3 drops of sodium hydroxide. If we have a very good buffer, then what will happen? The pH will read what? Unchanged, correct? Around 9 to 10 maybe, or 8 to 9. It will be not changed. That's with the assumption that our buffer solution are fresh and not decomposed, and they have to resist any change of the pH, correct? Now, I added HCl to the number 2, H2O, distilled H2O. I added 3 drops of HCl. What do you think the number 2 test tube will be the pH only. Somebody will tell me? Will be what? Will be acidic, correct? HCl is acid, correct? Will be acidic. Will be around what? Acidic will be around what? HCl. Maybe 2 and 3, correct? Around 2 and 3 will be acidic. So, how about the pH number 3 buffer? We added to 3 drop of HCl. Will be a change? No. If it's a good buffer, it should not have an effect, and the pH will be around 2 and 3. Everybody's following? And buffer number 9 solution with the pH 9, we added 3 drops of HCl. The pH will remain around 9, the range 9 to 10 or 8 to 9. Correct? So no change. So the idea of the buffer is made of a weak acid with weak base with their corresponding conjugated acid or base or salts, correct? And those are compound combination. They will resist any change of the pH. What is the most important buffer in our body that will resist any change of the pH? Somebody will tell me? Which one? Which one? Our blood. Our blood is the best example of what? Of a buffer solution. The blood is about what? 7.4